All right, so I'm just going to go over your mixtures and solutions test study guide. You can replay the video as many times as you want to. You can pause it, rewind it, etc. to get the answers. I just want to make sure you guys all have opportunity to get all those correct answers. So, okay, 4 methods of separating that we've done. We've filtered using the filter paper. That was that coffee filter, the screen, the metal screen. We've evaporated, letting all the water rise out, or you can just sort by the physical property, like with hand, which only works for a mixture. But if you think about like how you pick foods out that you don't like, that would be what you would do. The chemical we worked with that was the most soluble was the citric acid. It would have been considered highly soluble versus the others that might have been moderately or insoluble. Saturation is when a solvent can't dissolve any more solute. It's full. Okay. You know when a solution's become saturated because there's extra material at the bottom. If you don't see that extra material at the bottom, then it's not saturated. In order to separate a mixture of gravel, diatomaceous earth, salt, and water, you would want to get the salt to dissolve in the water, then use the screen to separate the gravel from the mixture, the filter paper to separate the diatomaceous earth or powder from it, and an evaporation tray to let the salt separate from the water. It's one of the things that we did in one of the labs. Hot water always holds more because when the water is hot, the molecules have more space between them, and that allows that solute to kind of slip in between. If you guys remember back to that video we watched where the molecules separate out as the water gets warmer. Okay, these are things that we've seen as crystals. Snowflakes, sugar, kosher salt, Epsom salt, citric acid all create some type of crystals. You guys looked at kosher salt, Epsom salt, citric acid in here, and I showed you guys the sugar crystals, the rock candy. Snowflakes are just another item that would appear as a crystal. The greatest concentration of Kool-Aid is the solution that has 3 scoops of Kool-Aid and 500 milliliters of water. You could turn each of these into fractions, and from there you would be able to see which one was the largest if you made the common denominator. So your proof is kind of by going 1 over 500, which is equal to 2 over 1,000, right? This one's 3 over 1,000. This one's 1 over 1,000. Okay. And 3 scoops of Kool-Aid over 500, 3 over 500, which is equal to 6 over 1,000. So that's how we know that solution D is the largest one. The solution that we chose was the largest, and I just proved it up here with those fractions. It has the most Kool-Aid to the least amount of water. 2 solutions that are built at the same temperature and have different amounts of water added to them until they're saturated. The saturated is the key word. If something is saturated and it's made out of the same substances, then it doesn't really matter how much is in it. It doesn't matter if they're in equal volume or not, or whether they have an equal temperature. What matters is the fact that they're saturated. So what do we know about the concentration of both? The concentration is going to be exactly the same. Okay, does one have greater concentration to the other? Are they equal? They are exactly equal. And then I have done a little example here. If we had water at 75 degrees, both of them at 75 degrees, but I had a small cup and it had 50 milliliters of water in it, which it takes about 15 grams of salt to saturate it. Then when I had 100 milliliters, in order to saturate it, it would take 30 grams. So these fractions would be equivalent. Okay, so 15 50ths is the same thing as 30 hundredths. They're equal fractions, so both cups would be the same. Bubbling, okay, remember we talked about bubbling is not a very scientific term. So bubbling indicates that a chemical reaction has occurred and a gas is formed and is being released. So make sure you're talking about gases being released. The state of matter they are is a gas. Okay, if my Kool-Aid was too sweet, how could I dilute it to make the mixture better? Well, you would add more water if you were diluting it. 3 pieces of evidence that water has made a solution. The salt and the water make a solution because the salt dissolves, so you can't see it anymore. That means the water's clear. Definitely the water level rises and the weight increases. There's no material at the bottom. Evidence that you would look for to tell that a salt solution had become saturated, that's where you just want to see that undissolved salt or solute at the bottom. The most concentrated of these, again, you can do equivalent fractions here. 1 over 50, 2 over 50, or 4 over 50, right? Well, 4 over 50 then, so C is the most concentrated, okay? They have equal volumes of water, but 4 has the most citric acid. If 1 scoop of salt weighs 5 grams and my solution has 4 scoops of salt and 100 milliliters of water, how much does it weigh? I asked you to show your work, so this is my work. 1 milliliter equals 1 gram. So 100 milliliters of water equals 100 grams. 1 scoop of salt equals 5 grams. It's given you that in the problem. So then I'm going to multiply 4 scoops times 5 grams is 20 grams of salt. So I have 100 grams of water, 20 grams of salt. I add those two up and I get 120 grams of solution in all. Okay. If a solution has 3 spoons of salt and 50 milliliters of water, it was clear with no material at the bottom. What would a solution look like that was 2 spoons of salt and 50 milliliters of water? Well, notice this one has more. So if it has less stuff in it, it would look the exact same, right? Because it has actually less stuff in it. It would be clear with no material at the bottom. Now, if it had more stuff in it, it could look different. Proof that a chemical reaction has taken place. Precipitate may form. Remember, a precipitate is the new solid material that forms. A gas may form and be released. The temperature change may occur, and there's one other that I don't have on here, but the color may change. So if you want to make sure you have that written down, then you'll have an extra one than what you might need for a question like that. Okay. Can the concentration of a solution be increased by constantly adding more material to it? Explain your answer. Yeah, you can increase by adding more material to it, right? If I have something that has little concentration, say I have water and it's got 5 milliliters of salt in it, I can still add more to it, and that will increase the concentration as the solute dissolves and absorbs in the solution. So then this is extending that answer out a little further. What would be the point when the statement a concentration can be increased constantly by adding more material to the liquid no longer be true? Well, when it has become saturated, there's no point. You can't add any more. One thing you might want to know is how to fix that. You could fix it by heating up the solution, because remember, we said that if we would heat up a solution, the molecules move further apart, and that would allow that solute to slip in there. So if you wanted to increase it, it's no longer true when it's saturated, but if you heat the solution up, you can get more to saturate in it and get a super saturated solution. Okay, we're going to look at these next diagrams, and we're going to answer some questions about them. So the first one is 2 ways that the students answered differently. Make sure when you answer this kind of question, you tell me all the ways that they answered differently so that you make sure you have 2. Terry made number 3 a solution and a mixture. Well, number 3 is lemonade. Is lemonade both a mixture and a solution? Yes. Lee said it was neither. Well, lemonade certainly is. Okay. Lee made only number 4 a solution, but Terry said it's both. So see how Lee has 4 out here. 4 is mud. Terry says it's both. Okay. Terry thinks that all solutions are mixtures, but Lee thinks that some solutions are not mixtures. Okay. All solutions are mixtures, so this one is more accurate there. Okay, they still both need some corrections made. So what's Terry showing by putting one circle inside the other? He's showing that all solutions are mixtures. They're just a special kind of mixture. Terry needs a correction. 4 needs to move into mixtures. So if you look at 4, it shouldn't be here. It should be out here, okay? Because it's mud, and water don't dissolve. Okay, what corrections need to be made to Lee's paper? He's got a lot more. Lee needs to put the solution circle inside the mixture circle because all solutions are mixtures. They're special kinds of mixtures. And number 3 needs to be moved into the solution bubble. Number 4 needs to be moved into just the mixtures circle. Okay, this diagram asks us some questions, so we're going to answer those questions about it. Okay, which picture shows the greatest concentration in sugar? So sugar is kind of your keyword. Think about what sugar is. Well, sugar is really sweet. So this one here is too sweet. So if they say it's too sweet, then that's the one that's showing that. Use the words concentration or dilute to tell me how you can make picture one taste better. And I would like you guys to be able to do both. So in order to make picture one taste better, it's super sour. You could add more sugar to make it more concentrated, or you could make it more dilute by adding more water, and that could help it. Okay, again, concentration and dilute, you're going to need to be able to use both to make picture two better. It was the one that was too sweet. You could make it more diluted just by adding more water, or you could make it more concentrated by adding the more lemon juice. All right, guys, make sure you understand the definition for these vocabulary words, know how to define them, understand what they mean. All right.